All right, we're doing mean, median, and mode and doing averages. The mean is just another name for the average, but we'll be using the mean, the median, and the mode. And so the mean is the average. The median is the middle number. When the numbers are ordered, and then the mode is the number that appears the most. If every number appears only once, then there's no mode. Choose the correct description of the mean. The mean is the sum of all the values divided by the number of values. It can be strongly affected by outliers. We'll talk about outliers later. Number one is E. The first part of number one is E. Choose the correct description of the median. The median is like the middle number. The median is the middle value in a data set. It is not affected by outliers. So after you write them in order, the median is the number in the middle. Choose the correct description of the mode below. The mode is the number that appears the most. The mode is the most common value in a data set. It is not affected by outliers. What are outliers? An outlier in a data set is a value that is much higher or much lower than almost all other values. An outlier can change the mean of a data set, but it does not affect the median or the mode. Here's an example. So if I have 1, 2, 3, 4, and 475 million, right? Then the median is the number in the middle, and this number is clearly an outlier. But no matter what this number is, the median is always 3 because it's always the middle number. But the average will always change because the average, you need to add up all the numbers and divide by the number of numbers you have. So the average is affected by this, but the median is not. Number 3. Briefly describe two possible sources of the confusion about average. So when we say average, sometimes people mean the mean or they mean the median, and so it becomes difficult to figure out which one they're talking about. Decide whether the following statement makes sense or does not make sense. In a data set of 10 exam scores in which no two people got the same score, the mean was equal to the score of the person with the third highest grade, right? So that is okay because the data set could be skewed towards higher scores, causing the mean to be equal to the third highest grade. So yeah, you can have them all listed out: 3, 4, 5, 6, 7, 8, 9, 10. And because it's just the mean and you're adding everything up, all the high scores could be on the end. That's D. Decide whether the following makes sense or is clearly true or does not make sense or is clearly false. Explain your reasoning. In my data set of 10 exam scores, the median turned out to be the score of the person with the third highest grade. No two people got the same score. This one is really hard because the median is always the number in the middle. And so if there are 10 people or 10 scores, 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, 7, 8, 9, 10, then the median for 10 scores is the average of the 5th score and the 6th score. So it can't be the third highest score. It has to be the one in the middle. Decide whether each of the following statements makes sense or does not make sense. I made a distribution of 15 apartments apartment rents in my neighborhood, one apartment had a much higher rent than all of the others, and this outlier caused the mean rent to be higher than the median. That completely makes sense, right? Because an outlier with a large value increases the mean, but does not impact the median. That was the example we did before when we have 1, 2, 3, 4, 5, right? I can have that. The median here is 3, but then if this number is higher, then the average goes up, but the mean goes up, but the median remains the same. The number of words defined on a randomly selected page or in randomly selected pages from a dictionary is shown below. Find the mean, median, and mode of the listed numbers. We can do the mode first. What number appears the most? And it looks like there are no numbers that repeat, which means there is no mode, no repeating numbers. To do the median, we need to put them in order. So let's put these in order. The lowest number is 30. Then it's, I believe, 37. Then 40, 42. And then it looks like it's 45. 47. 52, looks like 63, 64, and looks like then it's 76. Okay. The number in the middle. How many numbers do we have? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then with 10 numbers, 10 is even. So you go to the middle two numbers, 45 and 47, and you find the number in the middle of those, the average of that. 45 plus 47 divided by 2. 45 plus 47 divided by 2, the median is 46. The mean, we need to add all these numbers up and divide by 10. So let's go ahead and do that. It's 63 plus 37 plus 52 plus 30 plus 64 plus 45 plus 40 plus 47 plus 42 plus 76. Let's see what that is. 496, there are 10 numbers divided by 10. It's 49.6. Going to do something very similar here. Idea is the same. I'm going to leave this to you. Let's see if the mode, if there's a mode, oh, it looks like it's 0.16. So 0.16 appears. And then again, for number 8, put them in order. And here, add and divide by, looks like here it's 12. I'll leave that to you. Number 9. Cans of soda vary slightly in weight. Given below are the measures of the measured weights of 7 cans in pounds. Find the mean and median of these weights. what, if any, would be considered an outlier? All right, so looking at the numbers, there'll be some standard ways when you take a statistics class of finding the outlier. But here, if you're just looking at which one doesn't look like it belongs, all these numbers are 0.81 something, except for this one. And this one, in that sense, is different from the other ones, and it's lower. Now, the question is it that much lower? Well, relative to how the other ones differ from each other, this one is lower than all the other ones. All the other ones are the same to 2 decimal places, and this one is different. So this one definitely has an outlier that's much lower than everything else, and it's 0.7914. The mean, again, will add up all these things. .8159 plus 0.8191 plus 0.8164 plus 0.8173 plus 0.7914 plus 0.8141 plus 0.8124. And then we're going to divide by, looks like there's 7 numbers, 1, 2, 3, 4, 5, 6, 7. So then we're going to divide this by 7. Divided by 7 is 0.8124. Oh, it's at 5 decimal places, 0.81237. The median, if we write them in order, the number in the middle, well, there's only 7, so we're talking about the 4th highest number. Can we find this number here, the 4th highest number? Well, this is number 1, and then 8124, 8143, and then it's 4. This is the median, the number in the middle, 0.8159. Find the mean without the outlier excluded, right, and select the number choice below. So if you took out the outlier and just added these up, so then you would have 0.8159 plus 0.8191 plus 0.8164 plus 0.8173, and then you would add 0.8141 and then plus 0.8124. You would add those up and divide by, in this case, it would be 6. All right, so this equals 4.8952 divided by, we're going to do 6 equals 0.815. How many decimal places? 5 decimal places. 0.81587. So you would just add them up and divide by 6. The median without the outlier, or if we took out the median, or if we took out the outlier and then did the median, then we would then take the average of the middle two. So putting them in order, we would get let's put this one back. Then we would get, in order, we would get so we're taking out the outlier. So then what's the lowest one? The lowest one is then again 0.8124, 0.8141, 0.8141, 0.8159, 0.8164, 0.8173, and then 0.8191. Right, so then we've got 6 numbers, and then you would just take the average of these two. And that's 0.81615. Number 10. So just add these two numbers and divide by 2. For the following distribution, decide whether you expect the mean, median, or mode to give the best representation of the center of the distribution. Per capita earnings. So how much money you make can be affected by outliers. Here, affect the mean, right? So the median would be best, right? Because a person who's making $1 billion is somebody, if you include that person in taking the average, that person she would pull the average way up, and it wouldn't be representative of people in general, because not everyone makes $1 billion. Consider the distribution of exam scores from 0 to 100 for 84 students, where 39 got an A, 27 got a B, and 18 got a C, and compare complete parts A through D below. How many peaks would there be for the distribution? We would be expecting 1 peak, because we would not expect scores to be broken up into 2 different groups. So it wouldn't be something that looks like this one, right? There's no reason for groups to be like that. Lots of A's, and all the scores are high, and so the peak should be moving to the right. So we would expect this to be D. Here, this is saying all the scores should be in the middle, and here this is saying all the scores should be on the left. Here, we're going to say that this is left skewed, and so it has to do with where the tail is, right? So the tail is on the left, and so it's left skewed. Because lots of students got A's and very few people got C's, right? So it's left skewed. Variation is large because there are lots of different scores. The variation would probably be moderate. We would say the variation would probably be large because many students got an A, some got a B, and a small number got a C. And so the data are not all around the same values. The variation is small if the values are roughly the same. There's very little varying going on. Let's answer a similar one. Consider the distribution of the annual rainfall in 101 cities selected randomly throughout the United States. Complete parts A through D below. How many peaks would you expect? Well, there's probably only going to be a few places that have really high rainfall. So just 1 peak should be fine. There will probably be 1 peak because there's no obvious reason why the values would be forming in different groups. So again, the picture would not look like this one, right? And so where is this going to be skewed? This picture is probably going to look like this one, right? Because there's going to be a lot of cities that don't have a lot of rainfall, like low to moderate. And then there'll be a few cities that have a ton of rainfall, right? So we're going from low to high, right? You would expect that low to medium, there would be most of the people, most of the cities, and then there'd be a few cities with a bunch of rain. How does my math explain this? What shape would you expect the distribution to be? We would say the distribution would be right skewed. The tail will be moving to the right because there's a clear minimum amount of rainfall, but then there's no maximum amount. The variation again would be large because there will be some cities that have a ton of rainfall. There'll be some cities that have no rainfall. There'll be some cities that have some in the middle. That's a lot of variation. The variation would probably be large because there will likely be several cities that have different amounts of rainfall. Let's do another one. Consider the distribution of monthly sales of rain ponchos over a 1-year period at a store in Niagara Falls. The distribution will look best if we start in January. So it starts in January, and then it starts to move throughout the year. We're talking about rain ponchos. Okay, and this is in Niagara Falls. Okay. How many peaks? There's probably just going to be one peak. Let's see here. Rains in the summer in Niagara Falls. Rain ponchos, and it probably that's just when more people come as well to Niagara Falls to buy things. If we're starting in January, then that means that this one seems like it. So there won't be any ponchos. Then it gets to the middle of the year, more and more people buy rain ponchos, and then towards the winter, less and less percentage of the people are going to buy them. In the center, the variation is going to be, distribution is going to be symmetric because the distribution of monthly sales of rain ponchos has its peak in the summer months when the most people visit. Lots of stuff happening, not that much stuff happening in the early months or the later months, but in the middle months, there is lots of selling, so the variation would be large. Several months with very different numbers of rain ponchos sold. D. Exam results for 100 students are given below. For the given exam grades, briefly describe the shape and variation of the distribution. All right, so the shape, the mean and the median. So when the mean is, so when you're talking about skewness, follow the mean. If the mean is less than the median, right, it's left skewed. If the mean is greater than the median, it's right skewed. Right. Here, the mean is less than the median, and so this is going to be left skewed. And let's see what the variation is. So, the low score is 23, the high score is 82. So there's a big difference between the low score and the high score. So the values vary very much. The histogram in the figure shows times between eruptions of a geyser. Draw a smooth curve that captures its important features. This curve would look something like this. Right? That's clearly B. Looks like this distribution has two peaks. It is not symmetric. And the variation is moderate to large, right? The numbers vary a lot. Suppose you study family income in a random sample of 500 families. Your results can be summarized as the mean family income is $46,000, the median is $36,000, the highest and lowest incomes are $253,000 and $2,500. Draw a rough sketch of the income distribution and then choose the correct answer below. All right, so here we are again. The mean is greater, the mean is 46,000. It's greater than the median, which is 31,000. And so this means we are skewed right? That means that the tail is to the right. That would be D, but let's just make sure that's making sense. It does, right? So so what does this mean? This means that very few people are making that much money. Most people make the lower amounts. Because the mean is larger than the median, then this is right skewed. How many families in the sample earn less than 31,000? Well, 31,000 is a special number because it's the median. It's the number in the middle. So half the people have to make less than 31,000. Well, half of, how many people were there? There were 500 people. So half of that is 250. The median is the halfway point. Based on the given data, can you determine how many families earn more than 46,000? Well, 46,000 is the mean, and the mean is impacted by all these outliers, so it's hard to know what the mean is doing unless you know the distribution. We often deal with weighted means in which different data values carry different weights in the calculation of the mean. For example, if the final exam counts for 50% of your grade and two midterms each count for 25%, then you must assign weights of 50 and 25% to the final and midterms. All right, we're going to calculate our GPA here. So an A is worth 4. We'll just remember this table. An A minus is worth 3.7. So this person's GPA you get by taking the total number of grade points divided by the total number of credits. Well, how do you get a grade point? Well, for instance, this person got an A in a 3-credit class, and so this would be 3 times whatever an A is, and an A is 4, so that would be 12. This person got a B minus in a 4-credit class. A B minus is 2.7. Let's do 2, and then they got a it's a 4-credit class times a 2.7. So let's do 4 times 2.7. That's 10.8. So 2.7, that's 10.8. A C plus is 2.4. So 4 times 2.4, that's 9.6. And again, C plus in a 4-credit class, 4 times 2.4 is 9.6. And then 1 B minus is 1 times 2.7, which is 2.7. It was a 1-credit class. Then we're going to add up all of these. So it's going to be 12 plus 10.8 plus 9.6 plus another 9.6 plus 2.7. And that equals 44.7. And then how many credits was this person taking? It's 12, 15, looks like it's 16. 16 credits. So divided by 16, what are we rounding to? We're rounding to 2 decimal places to the nearest hundredth, 2.79 GPA. What grade would the student need to earn in French to raise her grade, her GPA to over 3.1? So now we're scratching out this grade and we're asking, well, what grade should this be? Right? So let X be the amount that this is worth. And let's see if we can calculate this. So that now French was the third one here. So that now the question is, this is X. What should this be now? So then it becomes, we're still going to add them, 12 plus 10.8 plus, now instead of 9.6, we're going to write 4 times X plus 9.6 plus 2.7 all over, how many grades do we have here? We still have 5. 1, 2, 3, 4, 5, over 5. And we want this to be 3.1, right? So to be, let's get more space over here. We want that to be 3.1. Okay. So now we're solving for X, right? So let's multiply by 5. Well, we can add these numbers up first. So let's add these numbers up first. So then we've got 12 plus 10.8 plus 9.6 plus 2.7, right? So that's that. So that's 35.1, right? So we've added up those. So it's 35.1 plus 4x over 5 equals 3.1. Okay. So, right, so it's not over 5, it's over 16. Credits, right? So then we're going to multiply. We're going to solve for X now. So we're going to multiply by 16. So then 3.1 times 16 is 49.6. So 35.1 plus 4x equals 49.6. We're going to subtract 35.1 on both sides. So then 4x equals, so subtract 35.1, subtract 35.1. So that looks like it is 14.5. And then we're going to divide by 4. So x equals 14.5 over 4. .625. That is the grade point you need. 3.625. What grade is that? Looking back at the scores, which one gives us 3.625? And that looks like an A minus. 3.625 is an A minus. A B plus will not be good enough. 18, you want to find the median weight of apples in a barrel. What do you need to do? Lay the apples out in order of increasing weight and find the weight of the apple in the middle. Choose the best answer to the following question. 100 students take a chemistry exam. All but 2 of the students score between 51 and 73, but one student gets a 23, which is really low, and another student gets a 95, which is really high. What do the scores 23 and 95 represent? We would call those outliers. They represent outliers. One is much lower than most of the values, and one is much higher. Choose the best answer to the following question. Explain your reasoning. A survey asked students to state how many sodas they drink per week. The results show a mean of 8 sodas per week and a median of 4 sodas per week. What can be concluded? So if the mean is 8, but half the numbers are less than 4, then that means there must be some numbers that are much higher. In other words, if the mean is 8, that means that there must be some number dragging this 4 up to 8. And so this means that at least one student drinks more than 12 sodas per week. An outlier value that is higher than most of the other values would explain why the mean is higher than the median. Choose the best answer to the following question. Explain your reasoning. The distribution of wages at a company is right skewed with outliers at the high values. Assuming you want a high wage, would you hope that your wage is closer to the mean, the median, or the mode? So it says that it's skewed right, so it's like this, right? So lots of people have this wage, and then there are a few outliers that are getting the high score, getting the high wage, right? So, but if it's right skewed, this means that the mean, follow the mean for skewness, the mean is higher than the median, and so if you wanted a high wage, you would pick the mean. Your wage should be closer to the mean because the mean is greater than the median and mode when the distribution is right skewed. Hope it helps.